Hey everyone, Professor Hank here. So today I'm going to give you a introduction to arrays in Java. So I want to talk to you about how you can create an array using references and the new keyword. I'm going to show you how to access the elements of the array using the subscripts or indexes of an array. I'll show you how to initialize it using an initialization list. I'm going to show you a new type of loop, the for each loop, which is useful for traversing all of the elements of an array without mistake. I'm going to show you some examples of processing arrays, and then we'll finish up by looking at how to create multi-dimensional arrays. So let's go ahead and get started. The thing to keep in mind here as we get started is that arrays in Java are different than, say, arrays in C++. They're more like arrays in Python, in that an array here is represented by an object. It's not just a contiguous chunk of memory that has all the values one byte after the other. Okay, there's an object, and so we can ask that object things. So for example, we can ask it what its length is. We can apply methods to it. Okay, so it's a little bit more sophisticated than some of the dumb arrays in other programming languages. So anyway, so let's start off and say that we want to create an array of 4 elements. So each member of an array is called an element, and each element allows you to store a piece of data. And the data that's stored in the array has to be all the same type. So it's kind of like a variable that can hold multiple pieces of data. So anyway, here's how we're going to do it. First thing we have to do is we have to create a reference. And so that reference is going to have a data type. It's going to have a name. So we'll say R0. And then you have to include the array notation, square brackets, right? Because if you don't have that, then it just looks like a regular old variable. Put the square brackets there, and then we assign to it an object, which we instantiate using the new keyword. We specify what data type it is, and then how many elements it's going to have. So in this case, the 4 is often referred to as a size declarator. So this dynamically allocates a new instance of an array object that is type int that can store 4 values inside of it. And the memory address of that thing is assigned to this reference called R0. And then we'll use that reference to access the different elements to store and retrieve values from those elements. Okay, so we can do that, but now keep in mind that you can put the square brackets on either side. You could put it to the right of the reference name here, or you could put it to the left. It doesn't make any difference. You can kind of see that up here, that the parameter for the main method here is actually an array reference for strings. Okay, so we'll go ahead and just leave it afterwards, okay, after the name, and then we'll show you how you can access elements within the array. So if I wanted to put a value in the very first element. Now arrays start counting, they start counting at 0, they're indexes. So this value that I put inside these square brackets here, it's known as an index or a subscript. So this is saying in that first holding place, I want you to do something. And what are we going to do? We're going to assign it 9. And then I'm going to say, all right, in the second holding place in the array, I want to assign 5. And in the third, I want to assign, say, 4. And then in the last holding place, I want to assign -5. Okay, so you can see that I've got 4 assignment statements here. I've got 4 separate indices or subscripts, and 0 is the number of the first element. Each element of the array gets its own unique identifying number. So in the first one, which is identified by 0, I put 9. And the second one, which is identified by 1, I put 5, and so on. So now I can retrieve those values. Let's say that I wanted to add the contents of the first and second element. I could do something like this. I could create a variable, and then I could do R0, and then I will say I want the first element from it, and then I'm going to add the contents of the second element. And then the sum of those two is going to go into my sum variable here. And so then I will print out the contents of sum. And I think this time I will use integer dot to string. And I will pass sum as an argument. Okay, because remember that what you give to print line here has to be a string. And so this isn't a string, it's an integer. So what I'm doing is I'm using the integer wrapper class and invoking its toString method and passing it the integer. And what it'll do is it'll return a string representation of what's in sum, which will then be sent to system.out.println. So let's go ahead and run that and test it. And we should see what, 13, right? Or 14, excuse me, 14, because 9 plus 5 is 14. Okay, so you can see that we can access those values. We can assign values, And then we can also retrieve values. And then you can overwrite those values too. Like let's say that I wanted to change that 9 to a 3. Then I would just do that. So then the 9 that was in that first element with subscript 0 with index 0 now contains 3. And so then I can do system.out.println, line, and I could do something like this. I could say R0 first element, and then a little shortcut here so that way you don't have to do this little integer.toString thing, is just to do plus and then an empty string. And then Java will do a concatenation and convert it for you automatically. Okay, let's comment this out because I don't want to show that again. And so now we're going to see that it's got 3. Okay, so there's the 3 right there. Now we can use a loop to traverse the array. So this subscript, or these indices, right, I'm using those names, are kind of synonymous, it has to be an integer, a whole number. Now, whether that's an integer literal, as we're using here, or a variable, doesn't matter. You can use either or. So let's say that I assigned 9542, and I wanted to print the contents of the array. Well, then I could use a loop to do that. I could say for int I equals 0, I less than R0 dot length I plus plus, right? Because I can ask the array, well, how long are you, right? So in this case, it's going to return 4 because there's 4 elements as we specified here. And so when I is 0, that's less than 4. When I is 1, that's less than 4. When I is 2, that's less than 4. When I is 3, that's less than 4. So that'll traverse all 4 elements of the array. And so I just want to print them out all on the same line. So I'm going to do system.out.print, and then I'm going to do R0, and I'm going to use as the index, as the subscript, I. So when I is 0, we'll be accessing the 0th element. When I is 1, we'll be accessing the 1th element, and so on. Remember, those are integers, so we have to convert what's retrieved from that element into a string, and so that'll do it right there. And we want to have a space in between each number, so we'll, instead of making that an empty string, we'll just put 1 space in there. So let's see that in action. We should see 9542 all in one line, and we do. Okay, now let's say if we wanted to figure out the sum of all the values in the array, right? So then I might do something like this. I might create an accumulator variable, initialize that to 0. And then for each element in the array, I would add the contents of that element to my sum variable. And then that would allow me to print out my sum. So what should that sum be? It should be, 9 plus 2 is 11, plus 9 is 20, right? So let's see if it calculated it correctly. And it did. This is examples of us doing some array processing, right? So we were talking about some array processing examples. Okay, now what if I wanted to find the highest number, the biggest number in the array? And I'll make this a little bit longer just to make it more interesting. So we'll do 5 elements this time. And I will assign to this 4th element, 8, and then I'll put inside of here in this 3rd element 22. So in the 5th element we put 8, and then in the 3rd element we put 22. So what I'm going to do is I'm going to create a variable that's going to keep track of the highest number found so far. I'm going to start by assuming that the highest value is in the 1st element, and then I'm going to start looking in the 2nd element. So I'm going to say, well, if what's in the ith element is bigger than what's in highest, then obviously we should replace what's in highest with what's in that ith element. Okay, and then we will print out the contents of highest. So let's go down here and change this to highest. So the biggest number by doing inspection should be 22, right? So let's see if that's what we actually see. And there it is. That's the highest number, 22. Okay, so let's look at how you can use an initialization list to initialize the array. So we don't have to do this. This is kind of gross, right? Try not to repeat yourself, all these assignment statements. If we knew that we wanted to start the array off with 9, 5, 22, 2, and 8, then what we can do is we can put inside of curly brackets up here, we can just put all those values separated by commas. Okay, so we can do something like that. And we have to get rid of the new int part right here. Okay, so when we do that, the compiler just looks at this and goes, oh, okay, well, you want me to put these values in an array and assign it to this reference here, so I'll go ahead and instantiate the array object for you, right? And so then we don't have to have all these extra assignment statements here. So let's double check, make sure that we still find 22 as our biggest number, and we do. Now, if we wanted to find the lowest number, well, then that's easy enough. We'll just create another variable called lowest. We'll assume that the smallest value is in the first element, and then we will search the rest of the array. And if, similar logic here, it'll be very similar. If the ith element has a value that's smaller than what's in lowest, then we will replace what's in lowest with what's in the ith element. Okay, so then we will just say something like highest value is, we'll do plus there, and then we will do lowest value is, and then we'll do lowest here, and let's give it a shot. So what are we going to see? We're going to see the lowest is 2 and then the highest is 22. That's what we should see. And so the highest is 22 and the lowest is 2. Now, let me show you an alternative to this for loop here, because this for loop right here can be prone to some problems, right? So for example, what if you start the I at the wrong place, right? If you start looking in the wrong place, you want to search through the entire array. Well, if I initialize this to 1, I'm skipping the first element for good reason in this case. But what if I wanted to print out the entire thing, right? What if happens if I wanted to do something like this, like I did before, and I was going through and printing out the whole thing, going system.out.print, and I was doing r0i plus space, right? Then this is kind of a problem. This is known as an off by 1 error, because I started the traversal of the array at the wrong place. I should see 9, 5, 22, 2, 8 if I wanted to see the entire content of the array, but instead I see 5, 22, 2, and 8. Why? Because this was initialized to 1 and not 0, and so I skipped the first element. It's easy mistake to make. So what you can do alternatively is you can use what's known as a for each loop, and a for each loop guarantees you that you're going to iterate over every single element of the array. So let's take a look at it. So we're going to have the for keyword, we're going to have parentheses again. We're going to have a variable that we define here that's going to be assigned through each repetition the value that's in each element respectively, right? So I'll do that, and then I'll do the name of the array that I want to iterate over. So what's going to happen is as this loop is repeating, it'll start at the first element, it'll copy the 9 into this target variable num here, and then within the array itself, then I can just retrieve that value. So the 9 will be copied from the array into num, and so then I'll print out the num. And on the next repetition, the 5 from the array will be copied into num, and then I'll print out the num. On the next repetition, the 22 from the array will be copied into num, and I'll print out the 22, and so on. So you'll see that this is going to guarantee, just because of the syntax, because of the way the loop is built, that you're going to iterate over every single element. It's safer. There's less chances of you accidentally writing your test expression in a traditional for loop incorrectly, or initializing your counter variable incorrectly, or whatever. This guarantees that you're going to move across the entire array. Okay, so a better way to find the sum of our array would have been to use something like this, because this will guarantee that you get to every single element of the array. And it actually looks a little bit cleaner too, right? And so then at the end, we'll print out that sum. We'll do print line, and then we'll do sum is, and then we'll do sum. Then how about we put a little period at the end? Okay, so let's test that. Okay, and then you're going to see that the sum is 46. So 9 plus 5 is 14, plus 22 is 36, plus 2 is 38, plus 8 is 46. So we got the right answer. Now, what if I wanted to find the average? What if I wanted something like this? System.out.println average is, and then did average. Well, I would need to know how many elements there are in the array. Now, I know that there's 5 because I created the array, but what if I didn't know? What if I didn't want to have to worry about that? Then I might put a little counter in here. Count it up as we go. So my counter equals 0. Okay, and then I'll go ahead and put counter plus plus in here. And so then for every repetition, we'll count how many repetitions we have. And we're going to have as many repetitions as we have elements in the array. So when this loop is done iterating, counter is going to have the size of the array in it, right? So then when we want to calculate our average, we could go down here and say double average, because averages have floating point numbers. And then we can do a little bit of casting here. We can do something like double the sum, and then we'll divide by the counter. And then that'll give us our average, an accurate average. So it should be like, what was this? This was 46, right? So 46 divided by 5. And then we'll even, just for testing purposes, we'll say system.out.println total elements is, the total number of elements, is, and then we'll do plus counter, and then we'll period. Okay, so just little trick things you can do. Okay, and so then you can see the total number of elements is 5 because we counted 5 repetitions from our for loop here because it iterated over 5 elements of the array. The sum is 46, and then the average is 9.2 because 46 divided by 5 is 9.2. Okay, so that is examples of how to create a one-dimensional array, how to access the elements of the one-dimensional array, how to initialize it using an initialization list. Okay, and the for each loop, how that works, as well as some examples of processing the array. So we found the sum, we found the average, showed you how to find the highest value, the lowest value, and so on. So let's finish up by seeing how you can create multi-dimensional arrays. So we'll look at how you would create a two-dimensional array. So two-dimensional array, think of it as a table. You got rows and columns. So we'll do integers again just to keep it consistent. So we'll say integers, and we want 2 dimensions this time. We want rows and we want columns. So we're going to need 2 of these square brackets, and I'll just name it A this time for array. And then we're going to have that same new int as well. And then we're going to have 2 square brackets. And then we're going to say how many elements we want in each row. So that's going to be, let's say 4 columns. Right, so each row will have 4 elements, and that's going to be 4 columns. Okay, now how many rows should we have? Let's say we're going to have 3. So that's going to create a 3 by 4 2D array. So each row has 4 elements, and we have 3 rows. So this creates an array of arrays, essentially, to where, each element of our array of arrays is itself an array. So how do we access individual elements then? Well, then what we do is we have 2 subscripts. We have 2 indices. So I could say A0 of 0. So that's in the first row of the first column, I'm going to assign 5. And in the first row of the second column, I'm going to assign 1. Yeah. Okay. And then if I wanted to assign values into the third row, and I wanted to put them into the third column, then I would do that. And let's say that I'm going to put 4 there. Okay. So you just add an additional subscript, an additional index, an additional size declarator. So if I wanted to assign values to every single one of those elements, then I would need to use, or if I wanted to traverse every single one of the elements of this two-dimensional array, I would need to use nested loops to do this. Now, what I'm going to do here is I'm going to make a couple of constant values, okay, a couple of final constant, never changing variables. And I'm going to have 1 for row, and that's going to be 3. And then I'm going to have 1 for columns, and that's going to be 4. And so I will use those in here instead to show you that you can use variables, or in this case, finals or constants, right, in C++ lingo, to serve as your size declarator for creating the two-dimensional array. So that allows me to do something like this. So I can say for int r equals 0. So for each row, okay, and so long as r is less than the size of the row, we'll do r++. So for each row, then we're going to have to do something for each column. So then I'll do something like another for loop here. I'll do for int c equals 0, c less than col c++. So what this is going to do is the outer loop is going to traverse rows, and the inner loop is going to traverse columns. Okay, so for each array in our two-dimensional array, in our array of arrays, that's what this is talking about. We're going to traverse every single element. So I might do something like this. I might say A, R, C equals 88. So we're assigning to every single element in that array the values 88. Okay, and so then what I could do is I could, once all that's done, maybe total up, find the sum of all the values in the two-dimensional array. So then I will have my nested loops again, r less than row, r++, and then I will do for int c equals 0, c less than col, c++, and then I will add to the sum the contents of each element of each column of each row. So let's create our variable here. Int sum, we'll store that, and then we will print out the contents. Then we'll do sum plus empty string. Okay, so let's test that. So this first set of loops is going to assign 88 to every single element, and then the second set of loops is going to traverse every single element, row by row, column by column, and taking the value in there and putting it in sum, and then we'll print out the contents of sum. So big idea here is that, there's the sum right there. So that's, 88 times 12. There's 12 elements, right? Because the number of rows times the number of columns is how many elements you're going to have. Because each row has got 4 elements, and there's 3 rows. Okay, so you can see 1066, so 88 times 12 is 1056. Okay, so now let me show you how to create a two-dimensional array using the initialization lists, and we'll make it maybe a little bit more interesting, or give you a different feel for it anyway. So we'll just do the integers again. Okay, and we're going to have our reference. And then what we're going to have is our array of arrays. So what we're going to do is we're going to put inside the initialization list, we're going to have an initialization list of initialization lists for our array of arrays. So that's the initialization list that you can think of as going into the array itself. And then we need to have a set of rows, right? So each element of the array of arrays is going to have its own array. So if we want to make this thing, say, 3 rows high, then we would need 3 initialization lists. Right? So in each one of those, we're going to put some numbers. We're going to put, I don't know, 1, 6, 3, and then we'll put 4, 2, 3, and then we will put 7, 9. Okay, so now you can kind of see, that table kind of forming, right? So we've got 3 rows. So there's 1 row, there's 2 rows, there's 3 rows, and then for each row, we've got 3 elements, right? So row, 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 but then we've also got 3 columns. So there's the first column consisting of 147, second column 629, third column 338. So this is a 3 by 3 array. So it's a square, right? Because the rows and columns are exactly the same. Now, if I wanted to go through and add up the sum of all of those elements, then I could do the nested loop thing again. But this time, let's see if we can figure out how to use the for each loop for this. Now, I want to ram home that you can think of this as an array of arrays, right? So this array right here would be part of the first element of the array of arrays. This would be the second element of the array of arrays. This would be the third element of the array of arrays. So remember, when you traverse a one-dimensional array, you're going to have this target variable here, and you're also going to have where it's coming from. So we're going from this two-dimensional array, and we have to copy that to somewhere. So where am I going to copy it? I'm going to copy it into this array reference. Okay, so what's going to happen is it's going to come up to this two-dimensional array, and it's going to extract this first row, this first array, this first element, more precisely the memory address of it. And then that memory address is going to get copied into row, and then from there, I can traverse it. So then I could do something like for int call. Right now we're just going element by element, and each element itself is an integer, right? In the row, do what? Sum plus equals call. Okay, and then let's create our sum variable. So let's see the results of that. And that's kind of complicated, right? That's kind of hard to wrap your head around. So 43. So the total of all the values in the array, in the two-dimensional array, is 43. Does that make sense? Well, 1 plus 6 plus 3 is 10, 14, 16, 19, 27, 34, 43. So yeah, that's correct. Now, what if I wanted to print out the contents of each element, or of each of the whole thing, row by row, say? Okay, well then what I would need to do is I would need to have my system.out.println, okay, and then that's going to be grabbing each individual value, right? So then I could do something like this. We'll print out call plus an empty string. So for this first example, we'll just print out all of the contents of the two-dimensional array on one line, just so you can see that the values are actually in there. So there you go, 1, 6, 3, 4, 2, 3, 7, 9, 8. And then where the 0 come from, it came from this. So I should comment this out. And also, let's put a space in between each of them and then try it one more time. Okay, so you can see 1, 6, 3, 4, 2, 3, 7, 9, 8. 1, 6, 3, 4, 2, 3, 7, 9, 8. Now, what if I didn't want them all in the same line? What if I wanted to print out row by row? Well, then after I print out the contents of a row, I should move to the next line. So that's what I'm going to do. System.out.println. Okay, so this will print out the entire row, and then this will just move the cursor to the next line. So you can see 163, 423, 798. So we'll start with the first row, taking the reference or the memory address from the first row, putting it in row. And then for each element in that row, we're going to print out the contents of each of those elements in the row. Once that's done, we'll move the cursor to the next line, and then we'll move to the next row. Okay, so there you go. There is a introduction to arrays in Java, how you can create a one-dimensional array, how you can access the elements of that array, how you can initialize it using initialization lists, how you can use the for each loop to make sure that you iterate over every single element within the array. I gave you some examples of processing the array, and then we finished up by looking at multidimensional arrays, and specifically two-dimensional arrays, and how you can process them using regular for loops and for each loops. As usual, if you're a student of mine, feel free to stop my Zoom office hours or email me with any questions that you might have. Thanks for watching, and we'll see you next time.